Hi, so this is a short video on estimation, specifically with addition as the context. So why do we estimate? We already have an algorithm for addition, right? So why do we need to do this at all? You can think about this for a while. If you want to pause, you can pause the video at this point. Okay, I'll give you a few contexts where estimation comes in. Let's say you're planning a wedding. Do we really know how many people are going to turn up? Mostly no. But still decisions are made. Maybe 100 people from the groom side, 200 people from the bride side. You total them, maybe add like 100 more extra people just in case, right? And now we make decisions on the number of chairs, the amount of food, and everything. So here we don't really know what values we are going to add. This itself is not very accurate. So why bother doing very precise addition on this? All right. Another context. So for example, let's say you want to cook how rice and sambar, but you have to leave in around 2 hours. Will I be able to make the rice and sambar within 2 hours? No, at this point, do we really need to know exactly what amount of time will it take, or roughly whether it is at least less than 2 hours? No, right? Like we just need to know a rough idea. So these are situations where estimation naturally comes in. And I can guarantee you that in your life, most of the things are estimated. So we can give children many contexts like this for estimation to come in. This is also an opportunity to explore or develop an intuition for addition, and also work on their number sense as well. If we directly give an algorithm, then they will just use that. Instead, what we can do is we can slowly try to give them opportunities to arrive at a way to estimate and develop that through intuition. So regarding that, we will see it through these 3 type of questions. Okay, so here's the first question. So I have 30 chocolates and my friend has 24 chocolates. How many chocolates would I have in total? So now, before they pick up their pen and paper and try solving this question, you can tell them to guess the answer. Now here, if you see, there are interesting guesses, less than 10, less than 20. What is this nonsense? Why would it be less than 20? So this may be obvious for us, but children might be thinking in terms of just as a black box. So their addition could be, so I have 2 values, I just feed this into a black box, which is our algorithm. I get something and this is my answer, whatever that may be. So if this is the idea that children have, they might not realize that it should be more than 20, it should be more than 34, right? And through this guessing game, we could try to bring this out. So a way to do it in classes, who all do you think it is less than 20? Can anybody raise your hands? Or you can pull up a few people and ask them, do you think it is less than 20? Do you think it is more than more than 50? Questions like this. And also you can ask them if they make a guess. Not all the time they make a guess, but some of the times they make a guess. You can ask them, why do they guess? So, both for what is perceived as a wrong answer or a right answer. So here it is guessing, no? So we can think of there are no wrong answers, and we are trying to get closer and closer to the correct answer. That's it. And now however, for a child who is guessing very off and a child who is guessing very close to the answer, in both cases you can ask them why they did so. And there's also an opportunity to bring out their strategies and strategies that works, that the ideas that does not work in class. All right. So now you can also play around with varying these numbers according to the question, as well as putting some landmark values like 50 and 100, because like a value like 69 or 79, they might not be able to feel it. All right, so this is like one set of questions. So here is another one. So I have 40 chocolates and my friend is giving me 35. It's not a different context, but rather like a different way for them to guess. So here I've drawn a number line. Now they have to guess on the number line. So they mark a point and then they can solve it and then come back to it and see whether they've gotten the right answer or not, or close to the answer or not. Here we don't have to ever stress on like, oh, you right answer, but rather how close are you? And it is okay if you are off also. The idea is over time we get closer and closer. Okay, so here just the idea that they have to take a pause and not use their pen and paper and think in their minds this itself provides a need to bring in idea of estimation strategies. For example, children might come up with this idea of, okay, I'll count up in tens, 40, 50, 60, 70. So strategies like this might come up naturally from them itself. Okay, so this is another style of questioning. And this also very closely relates to what you are asking as well in terms of the algorithm, right? So you want to, within that 10 value, can we estimate? So that is what we are leading to anyway. And here is another way in which you can give, your guessing options. So I have 50 chocolates and my friend is going to give me some chocolates. I don't know how much she's going to give me, but I know it is going to be less than 10. Right? So now can you guess how much chocolates will I have? So here, will it be more than 100? No. I mean, it's just very small, no? So it can't be more than 100. Can it be more than 70? I guess the maximum thing can be 10, right? So I don't think it should cross 60. So ideas like this, they can develop. So here also you can vary this, right? So here I've asked less than 10. You can also say between 20 and 30. She has chocolates between 20 and 30. You don't know. She has not really counted yet. Okay. Such context will also help build this idea of estimation. All right. Thank you so much.